We're finally going to learn the third form of a linear equation today, and it's called the point slope form. It's going to be really useful in a couple of different real world examples that I call case two and case three. You're never going to have to know what's case one and case two and all that, but they do progressively get a little bit more involved. So we will kind of review those ideas today. So what we're going to do is we're going to write equations of lines when given the slope, which is a rate of change, and a point, but that point is not going to be the y-intercept. So if you look at this case that we were talking about last time, if we have the y-intercept and we have the slope, it's very easy to use the slope-intercept form and write it in y equals mx plus b, done. But what if the point you're given is not the y-intercept? And that's what we're going to talk about today. Our next video will go even further. What if we don't have that rate of change? What if we don't have the slope? So today we're kind of on this red case. Before we do that, however, I thought we'd take a minute just to kind of review where we've come from so far. So the first thing I'm going to ask you is which of the following points are on the line? So this is a question that I want you to think about. Without graphing, is there a way to determine if these points are on the line? So you're going to come back and tell me which of these points, all four, how many of them and which ones really do reside on the line. And I'm asking you to not graph it. So how do you do this? Well, instead of graphing, you just basically do like a check. You're going to let x be 0. You're going to do the math. And if the output is 1, then this point would be on the line. And if it's not on the line. So in other words, -2 times 0 would be 0. Add 1 would be 1. That's a check. That works. -2 times -2 would be +4 plus 1 is 5. That works. -2 times 1 is -2 plus 1 is -1. -2 times 5 is -10 plus 1 would be -9, and that's a no-go as well. So basically, you would be looking at this, and I'm just going to show you the graph so you can see what would happen, but I'm going to graph that line. There is the y-intercept of 1 down to over 1. I draw my line, and then I plotted 0, 1. He's on the red line. -2, 5. She's on the red line. 1, 0 is not, and 5, -8 is not. So you can kind of see the picture there, but you didn't have to graph it to be able to do that. Okay, so the next one is find the rate of change for this data in the table. Did you remember to come and take any 2 points, any 2 that you want, take the change in y over the change in x and simplify it, and that will be your slope. Rate of change is another word for it. Usually we use it with units, but so if you take -2 minus 4, it would be -6. And 5 minus 2 would be 3. -6 divided by 3 would be -2. And it doesn't matter which 2 points you pick. I'm showing you it works all the way down. And even if you'd picked the top and the bottom and simplified, you would have gotten still that -2. So the rate of change, or slope in this case, would be -2. All right, now you're going to graph the equation using the x and y intercepts. This was called standard form. So I'm going to ask you to do that. And then once you graph it, identify 3 other points on the line. Okay, so let's see how we did on that one. So if I want the x-intercept, I can just kind of cover that over, make it 0, divide by 2. 8 divided by 2 is 4. And on the x-axis, I would put a point. And then if I cover over the x, putting a 0 in there, divide by -1, the y-intercept is -8, connect, and there's my line. Now, to be honest, you can also solve this to get the slope if you subtract 2x, or subtract 2x, I should say, and divide by -1, the slope would be 2. So you take any one of these points and go up 2 and over 1, up 2 and over 1, up 2 over 1. Those would all be points. If you draw your line accurately, you will see them in the crosshairs as well. So I have a whole bunch over here that I have named. So just some review of what we've been working with the slope-intercept form of a line, slope and rate of change, and also our standard form. So let's get back on track today to talk about this new form. So the usefulness of the slope-intercept form is when you are giving a problem where you see the rate of change, you see something changing, like the hot air balloon that was leaving Jacksonville, Florida, and we knew the rate it was rising, how many feet, I think it was feet per minute there, then that would be the rate of change. That's your M. And then we knew it started a certain number of feet above sea level, and that was your B. And you're able to just kind of write it in y equals mx plus b form. In this case, it's an algebra example rather than a real world example, but you can see the slope and you can see the B, and you just put it in y equals mx plus b and you're done. So case one problem, when you're given the slope and the y-intercept, it's the easiest to get into an equation. So today we're going to change. And this time, instead of giving you the y-intercept, it's a different point in time. It's not your start point, it's some point in time. So here's an example algebraically. Let's say our slope is 2, there's our m, but we don't have the b. This is not the y-intercept. So we have a new form of a line that we can use to calculate this. Now, there is a way to do it with slope-intercept, but the point slope form is a great way to start. It is a horrible place to leave an equation. We'll learn that in this video, but it is a really easy way to kind of start when you're given this case. So I'm going to give it to you right up here, in a second here rather. So here are the three. So we did the slope-intercept form when you have the slope and the y-intercept. We talked about standard form. And now we're going to talk about the point slope form. And I'm kind of color coding it here to help you. But basically, the x and the y are your variables. They represent all the points on the line. Now, you're going to get a specific point, a specific and y coordinate, and you're also going to get the slope. So you take the y variable minus the y coordinate that you're given. It'll equal the slope time, in parentheses, the x variable minus the x coordinate. So y minus y coordinate equals the slope times, in parentheses, x minus the x coordinate. And this is called the point slope form. So just to give you an example, the one we were talking about, you're given the slope. So the 2 will take that m spot. And you're given an x coordinate. The 3 will follow the minus after the x variable. And the 4 will follow the y, the subtraction after the y variable. So this would be the point slope form of this problem. It's just a matter of substituting things in the correct spot. Number one mistake is to swap the x and the y coordinates. So be careful of that. So we're just going to put things in right now. So we are going to write an equation of the line with a slope of -2 through this point. Go ahead and try it yourself. So when we do that, this is kind of what it looks like. Y minus the y coordinate equals the slope times x minus the x coordinate. Now this is a little sloppy here. We would not leave minus a negative. That would become a plus. So this would be the appropriate point slope form for this problem. Okay, try another one. So y minus the y coordinate equals slope times x minus the x coordinate. And again, let's clean up these double negatives. I'm having a hard time speaking today. And make that y plus 5 and 4 times x plus 3. So what you'll notice is if the coordinate is positive, the minus kind of sticks. And if the coordinate is negative, you end up with a plus there. That's going to be important if you're pulling backwards out of the point slope form. So now graph a line given in point slope form. So if you have a point slope form, which this is, it is really easy to graph the line. All you need to do is pull off the point and use the slope to move. So remember that it's x minus the x coordinate. So the x coordinate would be 3, and y minus the y coordinate. So the y coordinate would be 2. So we have our start point. Come over 3, 2, and put your point. Now use your slope to move. So you're going to go down 3 and over 2. And sure enough, if you do that twice, there's your line. So if you have a point slope form, it is easy to graph it. So given a graph, let's do the reverse. Can you write the equation in point slope form? So now I have a line and I'm going to go backwards into the point slope form. So I need points that are in the crosshairs here. So you'll notice there are a lot of different points in the crosshairs. I haven't given you just all of them, but you need to find the slope. So your rise over your run, and then you need to take a point off of the line. So the slope is 4. So if you count up 1, 2, 3, 4, 5, 6, 7, 8 divided by 2, 8 divided by 2 would give me a slope of 4. Now you have different points, right? So you could pick either of those points. So which one did I pick? Well, I didn't, because you could pick the point -2, 4. You could pick, which is this one right here. You could pick the point -4, -4. You could also pick the point of 8, whoops, excuse me, -1, 8, which is way up here. So those are all different points on the line. And here is the problem with the point slope form. And the reason I didn't say a point is because there's an infinite number of them. So because there's an infinite number of points on a line, there's an infinite number of point slope forms. So if you wrote any one of these, you would be correct. It is an equation of the line. So my point is, it's really horrible to use point slope form as an end point. It's a wonderful place to start. It is a horrible place to end. So what we need to talk about is fixing that problem. So I took all 3 of those equations, and what I'm going to show you is how to write these in slope-intercept form. And you could take it further and do standard form as well. But right now, let's just fix these to make them into a slope-intercept form. There is only one slope-intercept form for a line. So what we're going to do is we're going to just do some algebra here. So do you see the parentheses? Let's do the distributive property. So 4 times x plus, don't forget the second piece, 4 times 4. Oh, and that should be an equal. So let me fix that. So having said that, I don't know why that showed up like that. There we go. So now you're going to need to subtract 4, and this is where I'm releasing you from the steps. So if you subtract 4 from the left, it goes away, and now you're going to subtract 4 from 16. So notice I didn't write the -4 on both sides, and if you can go from here to here correctly, you are good. All right, let's see if I have that same equals issue over here. So distributive property, 4 times x plus 4 times 2. Nope, I'm good. And now I need to add 4. And when I add 4 to both sides, notice I will get the same slope-intercept. That's because for a given line, there's only one y-intercept and only one slope. But for point slope, yes, they all have the same slope, but they will have different points. Does the last one come to this same thing? 4 times x plus 4 times 1. And this time I'm going to add 8, and sure enough. So on the assignment, a lot of time your book fails in saying to write it in the slope-intercept form, the y equals mx plus b, but I always want you to do that. Don't leave an equation in point slope form. It's a wonderful place to start, a horrible place to end. So once again, this is kind of what I just showed you. I just wanted to have one slide. How do you convert from point slope to slope intercept? You do the distributive property, and then you're going to solve isolating for y. And that's how we solve a point slope equation into slope intercept. Now remember, you could go a step further here and switch it to standard form, which we did in the last video, by moving that term, making sure there's no fractions or decimals, which we don't have to do here. But if you subtract the 2x and put it on the other side, you would be in standard form. Okay, so we're going to find the equation of a line with a slope of -1 that passes through this point, and I want you to make sure it's in slope-intercept form. So how about you try this one? Okay, so the first thing we're going to do is put it into point slope form. So the x coordinate is going to go in after the minus, following the x. The y coordinate is going to go after the minus, following the y, and the slope takes the m spot. Kind of a mess over here. Remember, that's a +2, and we're going to do some distributive property. So we're going to distribute the -1 to both pieces. Oops. And there we go. And then we're going to subtract the 2, and voila, there is our slope-intercept form, y equals mx plus b. So here would be the cleaned up point-slope form, and here would be the slope-intercept form. And if we wanted standard form, you would just add x, and you'd have x plus y equals 3, right? So those are all three forms come off of this point-slope form. And here is the line, y equals -x plus 3. So you can see there is the y-intercept, down 1 over 1. You can see that. And you can also go back and just remember the 0.5 -2. And if you look at the 0.5 -2, this line is going through it. The point-slope form is a wonderful place to start to find the equation of a linear function. It's kind of a horrible place to end because there can be an infinite number of point-slope forms of a line. So that's why I'm going to ask you to always make sure that you take it a step further at least and go to your slope-intercept form, your y equals mx plus b. That way, everybody has the same answer. So it's time to practice using this third and final form of a linear equation. It's called the point-slope form. And we will practice individually, and then we'll come together and look at it again. We will be doing more with this coming up in the next video. Guys, have a great day. I will see you soon.